All right, we're back. We are on page 8 of notes 5 of Calc AB. We're in the middle of a mean value theorem-ish problem. I mean, we're in the middle of the mean value theorem notes, so it'll probably come up. And we're dealing with this graph. We have a bunch of information about the graph there. And this is kind of like the second video on this, so I'm going to assume that you just watched the first one and just dive in. So we are on part C, and part C says, for how many values of a, -5 less than or equal to a less than 4, does the mean value theorem applied on the interval from a to 4 guarantee a value c where a is less than c is less than 4 such that f prime of c equals -2/5? And then there's a hint that says add a line. It's like the only time in your life you're going to get a hint on these types of questions, but you're supposed to use the hint to come up with like a general problem solving strategy. And one of the strategies is when you have to deal with slopes and things and you know specific points, try like adding a line. So where are we going to add this line? Well, we know that our interval is going to be from a to 4. So the definitive point that we know is 4. X equals 4 is definitely going to be one of the endpoints. Now, we're looking for f prime to equal -2/5, which means that if I start at the point 4 comma whatever, and I apply the slope, I can draw a line, right? The slope of the secant has to equal the slope of the tangent. They're giving us the slope of the tangent is -2/5, but that means the slope of the secant is also that. So what can we do? So if I start at this point right here, let's use a fancy color. Well, I don't really like the fancy colors, but let's use a color. Maybe this one. This one looks to me almost exactly like a color I've used, but we start at 4, -2, and we're going to use the slope, which is -2/5. So I could go 5 over and 2 down, like 5 to the right and 2 down, but I can't really do that because the graph doesn't work that way. But if I go 5 back and go 2 up, it does work that way. So 5 back and 2 up is going to take me to -1. What the? Oh, I'm on the eraser. -1, 0, actually. So now what I'll do is I'm going to draw a line that goes through these. Well, I'm going to try to. Let's let it. Pretty good. Okay, so how does this help? Well, think of the picture of the mean value theorem, right? The picture of the mean value theorem, we have the slope of the secant line, we have the slope of the, well, we have the curve, then we have, let me just draw it. The sort of generic picture is something like this, and then you have the secant line, and then you have, here and here. This is that in my mind. When someone says mean value theorem, I immediately think of that picture. Well, here we sort of have that. What issues are we dealing with? Well, mean value theorem only applies if a function is continuous on a closed interval, differentiable on an open interval. We already know the function is not differentiable at -1, which means that anything beyond -1 over here, for example, if we kept going, there would be another intersection point, and maybe I should have done that, but I didn't. I guess I could extend it now. Let's see. There, let's say. On this interval, MVT doesn't apply because not differentiable at x equals -1. So our answer has to be between -1 and 4. That's like kind of a given at this point. So I'm going to say that there's actually only one point at which this works. And that one point, we've actually kind of, I don't know if this feels very coincidental, and I have no idea what the equations were. This is the only point. This is the only value of, what are we calling this? Value of C that works. Because it's the only place the secant line that we're drawing using the given slope intersects the curve on an interval where the original curve is differentiable. So there's really only one value of C. So let's see what the question is and if we can answer it. Also, I just got an iPad Pro. It's way bigger than the one that I've been using. And that's why some of my zooming is probably like really weird on this video and on the previous one, but I didn't want to mention it. I feel like I should just address the issue though. That's why things are weird right now. I had a lot of practice with the old iPad, which was way smaller. This one's like a lot, it's amazing though. Recommended so far. I don't know how it'll go in the long run. All right, so for how many values? There's one value of A. So I'm going to say there's one value of A, and I don't know that there is one. Oh God. O-N-E, one value of A. So I'm going to say there's that period that I always put because the second potential value is less than -1. And f prime of -1 does not exist. So I think that that's a fine answer, right? So let's just go back to the picture and make sure we understand. So the first potential value that we saw was right, looking for a good highlighter color. This is not a good color. The first potential value that we saw is this one. The next potential value is this one, but since the function is not differentiable, the curve is not differentiable on that interval, mean value theorem doesn't apply. So that's why we are kicking that value out. So there's only one value of A. Adding a line is a huge deal. So when you're given this like weird information and you're not really sure what to do with it, try adding something to the picture, right? We did that twice. We did it for the horizontal line, maybe in part B, I guess. We added a line to the picture and we could find our intersections. Then we did it for the mean value theorem. So adding the line going to make your life a lot easier. The function g is defined by g of x equals e to the 3 minus f of x. Okay, write the equation of the line tangent to the graph of g at x equals -3. Okay, so we're going to need to know two things. We need to know what g of -3 is. So g of -3 is e to the 3 minus f of -3, which we can probably get from the graph. So maybe let's do that. So that'll be e to the 3 minus, let's go back to the graph. Where are you? F of -3. Oh, f of -3 is not like super easy to find. Cool. All right. So this equation is, so we know that we go through, well, we know we have a slope of down 3 and over 4, and then it goes through, I don't know, -5, 2. So I'm going to say it's y minus 2 equals, what did I say, -3/4 x plus 5. Okay, so that means that f of -3 is going to be 2 minus 3/4. -3 plus 5 is 2. So that's 2 minus 3 halves, which is 4 halves minus 3 halves, so 1/2, which like you probably could have guessed, but I would warn against guessing those sorts of things because, like, you know, you never know. So we got e to the 3 minus 1/2, which is 6 halves, e to the 5 halves. So this is going to be a nice looking tangent line. And then we also need to know what g prime is. So g prime of x is a chain rule. It's going to be e to the 3 minus f of x times the derivative of 3 minus f of x, which is just negative f prime of x. Okay, so then g prime of -3 is going to be e to the, so if you got that wrong, you're just going to, like, and maybe I did, I hope I didn't, but if I did get that wrong, I'm just going to keep using it. So e to the 5 halves times negative f prime of -3. To go back to it, I kind of remember it. I think it's -3/4, right? So yeah, we've used that several times now. The slope of this line segment from -5 to -1 is definitely down 3 and over 4. I keep saying it to reassure myself, but -3/4 is f prime of -3. So we get negative, well, this is interesting. We got negative e to the 5 halves times -3/4. So we get positive 3/4 e to the 5 halves. Okay, we're not done with the problem though, because we have to write the tangent line. So the tangent line is y minus e to the 5 halves equals the slope, which is insane, 3/4 e to the 5 halves, and then x plus 3. So one of the things that I like to do in the notes at the beginning of the year, because like it seems like in algebra, in algebra 2, and sometimes in pre-calc type things, definitely not in math analysis, they go out of their way to make sure the answers are like clean looking and you get a lot of integers or at least rational numbers and everything like works out. Calculus makes no attempt to do that. And you just have to get used to getting really gross looking answers and thinking to yourself, is it correct? Did I do it right? And if you did, like, you know that you're good. So this answer might scare you initially, but you do enough problems and eventually you just kind of like get over that. All right, we're done with this page, so I'm going to stop this here, and I'll be back in the next video to maybe finish the notes, but I don't know what's on the next page, so we'll find out. See you then.